Okay, guys, what we're doing today, still working with simplifying radicals. Last time we simplified them and we added them together, subtracted them. Now we're going to work on simplifying them and multiplying them. And then one other topic the last class didn't like, you may love it, is rationalizing the denominator. We did some of that last fall. We'll do some of it today with problems that are a little bit harder, okay? So the product property of radicals. The square root of AB is the square root of A times the square root of B. So anytime I see two radicals that are added, they have to be what? In order to add them, they have to be what? The same. Okay, you can only add apples and apples, to get apples. But multiply, I can multiply anything. So if I got two radicals that look very different, I can multiply them together. And sometimes multiplying will be the key to simplifying it. Okay, so before we get into multiplying, let's just review real quick what we're doing. Fourth root of 80, x cubed y 6. My goal is to organize under the radical as perfect what? Perfect fourths, powers of 4. Okay, I look at 80, it doesn't jump off the sheet to me, so I divide it by 2 and I get a 40. Divide by 2, I get 20. Divide by 2, I get 10. Divide by 2, I get 5. Is there a perfect fourth there? This is what? 2 to the fourth, or 16, times 5. Okay, so this is going to be the fourth root of 2 to the fourth times 5 x cubed, and then I'm going to write y as what? Y to the fourth, y squared. Okay, does everyone see why I do that? Okay, you can do some of this in your head, but I do this so that I can be organized and I can always check my work. Which of these things now is perfect fourths? Yeah, this one and this one. Okay, so what's the fourth root of 2 to the fourth? 2. Fourth root of y to the fourth? Y. And then what am I left with? 5 x cubed y squared. Okay, so if it's the fourth root, every exponent that's left under the radical has to be what? In my final answer, has to be if this is a fourth root, every exponent that stays has to be what kind of number? Less than 4, right? Okay, if it's 4 or greater, it comes out. It's simplified. Okay, let's look at the next one. The cube root of negative 135 m to the 5th n. How do I deal with that negative sign? Yeah, so if it's a cube root, if it's an odd root, this is the cube root of negative 1 times 135 m to the 5th n. What's the cube root of negative 1? What number can I multiply by itself 3 times and get a negative 1? That's negative 1. So I can make this problem easier. Just bring that negative outside. You can do that for any odd root. Okay, 135 m to the 5th n. So I'm trying to organize as things that are cubed. When I look at 135, how do you want to divide it? I start with a 5 because it ends in a 5. When I divide that by 5, that is 27. You start to see familiar numbers. You do this. Okay, we're used to working with 27. So if I divide that by 3, is there anything that's a perfect cube there? And we got 3 cubed. So this is minus the cube root of 3 cubed times 5. How do I write m to the 5th? Yeah, it's m cubed, m squared, n. So what's the cube root of 3 cubed? That's 3. So I get a 3m, and then what is left? 5 what? M squared n. Okay? And that's as simple as it gets. Okay? So we've done several of these. Now, let's look at what happens when we start multiplying radical expressions together. This one's pretty easy. Square root of 6 times the square root of 6 is what? Did I not have a negative on it? There we go. What's the square root of 6 times square root of 6? It's 6, okay? You know that. But you can write this. This is, according to our product property, the square root of A times the square root of B is the square root of AB. You can multiply them. So this is the square root of 6 times 6. That's the square root of 36, and we know that to be 6, okay? That was pretty easy, okay? Now, square root of 2 times the square root of 18. Square root of 2, I can't simplify that. Square root of 18, well, that is 9 times 2. But what I can do to make this real easy, this is the square root of 2 times 18. What's 2 times 18? 36. This is the square root of 36, which is 6. Okay, so just by multiplying what's under the radical, I got a perfect square in that case. Okay, if you did not see that, okay, if you didn't see that trick, you could write this as the square root of 2 times the square root of 2 times 9, right? What's this? How does this simplify? That's the square root of 2 times 3 times the square root of 2, right? What's the square root of 2 times the square root of 2? It's 2. So this is 3 times 2, which is 6, okay? So a couple of different paths. As long as you're obeying the rules of exponents, not doing anything that's illegal, you're going to get there, okay? Let's look at the next one. Now I'm multiplying two what kind of numbers? Positive, negative. Two negative numbers. This answer will be positive, okay? So it's going to be a positive number. But I'm looking at the fourth root of 18 and the fourth root of 36. Neither one of those jumps out at me. But what I can do is this. This is going to be equal to 5 times 4 times the fourth root of 18 times 36. Okay? So let's look at 18. 18 is divisible by 2. Okay? So that's what 18 is. Okay? 36. 36, you divide that by 2, you get an 18. Divide by 2, you get 9. Okay? So these are all the factors. Do you see 4 of anything? Yes. What do you see 4 of? Yeah, I see 4 3s. So this is 3 to the 4th times what? 2 to the 3rd, or 8. So this is 20 times the fourth root of 3 to the 4th times 8. Okay. What is the fourth root of 3 to the 4th? 3. So this is 20 times 3, and I'm left with the fourth root of 8. So the answer is what? 60 times the fourth root of 8. Hard, easy, medium, what is this? Okay, like I said, it's pretty straightforward. Your goal here is to organize things as perfect fourths. Now, I could not add these two things together. You see that, they're not identical. But I can multiply them, and when I multiply, so if you look at this, there was not, when I looked at the factorization of 18, there was nothing to the 4th power. When I look at the factorization of 36, there's nothing to the 4th power. But when I multiply them together, there is a 3 to the 4th power. That makes it simplify. Okay? Let's continue on with some of our multiplication. How do you think I multiply this? So let's just multiply this together and see if it can simplify. What happens when I multiply square root of 5 and square root of 6? What is that? Square root of 30 plus 3 times the square root of 5. Can I simplify the square root of 5? No. What about 30? So that's, if I divide that by 2, I get 15 Divide by 3, I get 5. Are any of those perfect squares? No. This is as simple as that one can get. Okay? Nothing can be reduced in there. Let's look at the next one. 10 times, square root of 10 times 2 plus root 2. Okay, so you distribute this. You get 2 square root of 10 plus the square root of 10 times the square root of 2. So this is 2 square root of 10 plus the square root of what? 20. Now, square root of 10, that's 2 times 5. I can't simplify that. Can I simplify the square root of 20? Yeah, so that's going to be 2 square root of 10 plus the square root of 4 times 5. What's the square root of 4? 2. So this is 2 square root of 10 plus 2 square root of 5. Okay? So that's multiplying it out and then simplifying the radical. By simplifying, meaning there's no perfect square. This is a square root. When I look at the square root of 20, there is a perfect square in there. It's 4. Okay? But when I take that out, I've got square root of 10, square root of 5 in my answer. There are no perfect squares anywhere in those two radical expressions. Looking at the next one, I'm going to multiply these two numbers together and get what kind of number? A negative number. Okay, so it's going to be negative what? Negative 12. And then I've got the square root of 3x squared times the square root of 3x. Okay. So I can do several things. I can simplify or I can multiply to begin with. Let's just go ahead and do the multiplication. This is 12 times the square root of 3x squared times 3x. Okay, that's negative 12 times the square root of, and I'm going to write this as 9x squared x. Why do I write 9x squared x? Yeah, because now, which of these things is perfect squares? This, okay? What's the square root of 9? 3. So I get negative 12 times 3. Square root of x squared is x, and I'm left with what? Square root of x. So this is negative 36x square root of x. Okay, how are you feeling about these? Similar to adding. I mean, the only thing about adding, it has to be you have to have exact matches in order to add them and combine them. Here, you can multiply anything. Okay, you multiply and then you simplify. Look at the next one. I'm going to multiply these two numbers and get what kind of number? A negative number, negative 4. And now I'm going to have the fourth root of, let's just go ahead and write all of this, 4 into the fourth times 20 into the fifth. Okay. So this is negative 4, fourth root of 80 into the fourth. How can I rewrite into the fifth? Yeah, right as is into the fourth times n. Okay, total of 9 n's, and they're all accounted for there. Okay, so now it becomes a matter of what is 80. If you don't know that, divide it by 2, you get 40. Divide by 2, you get 20. Divide by 2, you get 10. And 5. Do you see 4 of anything? 4 2's. So 80 is 16 times 5. The fourth root of 16 is 2. So I'm going to write this as negative 4, fourth root of 2 to the fourth times 5, into the fourth n. Which of these things is perfect fourths? Yeah, the 2 and the pair of n's there. Okay. So outside the radical, I get negative 4 times, what's the fourth root of 2 to the fourth? 2. And then Fourth root of n to the fourth is n. How many do I have? 2 of them. And what stays under the fourth root? 5n. So this answer is negative 8 n squared and the fourth root of 5 to the n. Okay? So the simplifying part we've been doing for several days now. The only thing new here is multiply. So you had to multiply and then simplify. And you can see that if you just simplify this and simplify this, you won't get into the simplest form. It takes multiplying these two things together under the radical and then simplifying it, okay? Because if I simplify this, I could only simplify the n, and the n, the numbers would stay there. It's when I multiply those two numbers together, I got further simplification. Okay? Okay, let's change gears a little bit and talk about something we did last semester, rationalizing the denominator. So rationalizing a denominator means looking at a denominator, manipulating it in such a way that there are no radical expressions in the denominator. The reason this was done historically, before we had calculators and you could just type in 1 over the square root of 2, it was easier to divide by a rational number than an irrational number, using a slide rule, logarithms, all of that. So that's why we do it. You just need to get comfortable that sometimes you'll see an expression, you know, like square root of 2 over 2 is the same thing as 1 over square root of 2. You just need to be comfortable, like, how did they get that? So that's sort of why we teach it today. So on the bottom of that fraction, I see the square root of 2, okay? Can I simplify the square root of 2? No. That's 2 to what power? That's 2 to the first, okay? 2 is 2 to the first. It would simplify, Henry just shakes his head. It would simplify if it was the square root of 2 to the what power? Second, because it's square roots. So, what can I multiply the square root of 2 to the first by to get square root of 2 to the second? Square root of 2. So, but I can't just multiply something by square root of 2. I have to multiply by 1 in the form of square root of 2 over 2. Okay? So the reason I do this is, what do I get on the top of this fraction? I get square root of 2. On the bottom of this fraction, I get the square root of 2 squared, the square root of 4. What's the square root of 4? 2. Okay? So this is the square root of 2 over 2. This has been rationalized, meaning there are no radicals in the denominator of this expression. Okay? These are equivalent expressions. So, you know that to take the square root, it simplifies if what's under the square root is a perfect square. The way to make square root of 2 is a perfect square is to multiply it by the square root of 2. That's why I rationalize by multiplying by square root of 2 over square root of 2. Okay? Something you know and love from last semester. Okay? Now, it got a little bit harder last semester when we saw something that looked like this. What did we have to multiply by here? Yeah, we had to take 2 over 1 plus root 5, and we had to multiply by 1 in the form of 1 minus root 5 over 1 minus root 5. That's the trick we had to do to this kind of expression to get the square roots to go away. When I multiply the top, I get what? 2 minus 2 root 5. And on the bottom, I'm multiplying two binomials. You learned how to do this with what? FOIL. So 1 times 1 is 1. Outside terms, you get minus root 5. Inside terms, you get plus root 5. And the last terms, you get minus. It's the square root of 5 times the square root of 5. Okay? So this becomes 2 minus 2 root 5. The whole reason we did this was so that what goes away? The square roots. You can see that those two things add up to be what? 0. What is the square root of 5 times the square root of 5? It's 5. So on the bottom you get 1 minus 5. Right? So this becomes 2 minus 2 root 5 over negative 4. Okay, so that is rationalized. It's not in its simplest form because what's 2 over 4? 1/2. 2 over 4 is 1/2. So this would be 1 minus root 5 over negative 2. So that's a form of the answer. A lot of times what we like is instead of having this negative 2, you could just distribute the negative. You could have minus 1 plus root 5 over 2. Either one of these answers would have been good. Okay? You remember this. We did this last semester. All right? Okay. Let's look at the next one. What must I multiply by to get rid of the radicals here? I can do square root of 20, but here's a key. That is the simplest form that square root appears. Now, so if I can simplify it the first, I can save simplifying later. And it's usually, if you can simplify at the start, it's usually going to be better. I can write the square root of 20 is the square root of what? 4 times 5. You could write it 2 times 10, but that doesn't help you. Why did I write it like this? Because that is 2 times the square root of 5. Okay? So this is 2 plus root 2 over 2 root 5. Let me see if I can write that a little bit better. Okay? So what square root in the denominator do I need to go away? Square root of 5. I can make the square root of 5 go away by multiplying by what? Square root of 5 over square root of 5. So I can write this as 2 plus square root of 2 over 2 root 5. And I'm going to multiply by square root of 5 over square root of 5. Okay? You're multiplying by 1 in the form square root of 5 over square root of 5 because what you want to go away is this square root of 5 on the bottom. So what do I get on the top? I get 2 square root of 5. What's the square root of 2 times the square root of 5? That's the square root of what's 2 times 5? 10. Okay. So I get square root of 2 times the square root of 5. That's the square root of 10. On the bottom, I get 2 times the square root of 5 times the square root of 5. What's, pardon me? Right here? To make this square root of 5 go away, I have to multiply by square root of 5 over square root of 5. Okay, so 2 square root of 5. The square root of 2 times the square root of 5 is the square root of 10. Here I've got 2 square root of 5 times the square root of 5. What's the square root of 5 times the square root of 5? That's 5. So you get, your answer here is, let me just keep continuing over here. You get 2 square root of 5 plus the square root of 10 over, what is this? 10. That's just 2 times 5. And that is your answer, okay? Everyone see that? Look at the next one. I see the square root of what that I need to go away? The square root of 2x needs to go away. So I'm going to multiply this by what? Yeah, square root of 2x divided by the square root of 2x. Okay? So on the top, I get 4x square root of 2x. On the bottom, what's the square root of 2x times the square root of 2x? It's what? 2x. Okay? So I've got 4x times the square root of 2x over 2x. What's 4 divided by 2? 2. What's x divided by x? X over x is 1. So the answer is 2 square root of 2x. Okay, you remember all of this from last time? Okay, we'll make it a little bit harder and then we'll be good to go. So, so what we've done so far, things that look like this, a over the square root of b. You multiply by 1 in the form square root of b over square root of b to rationalize that denominator. When you see something like this, a over 1 plus square root of b, you multiply by 1 in the form of 1 minus square root of b over 1 minus square root of b. You want to make those square roots go away in the denominator. Now, this is where it gets a little bit harder, so I'll skip the reading there, but let's just talk through the next one here. I want to rationalize 1 over the cube root of 2. What's different here that we haven't done? Cube root, okay? So just think about it. My whole goal with cube roots is I want to see under the radical something to the what power to simplify it? No? Cube roots. I want perfect cubes, okay? So here I've got the cube root. So if you think about it this way, I've got 1 over the cube root of 2 to the 1, okay? What I really want is, in order for that to simplify, I need it to be the cube root of something what? Something cubed. I've got something to the first power. What would I need to multiply by to get something to the third power? Cube root of 2, what? Squared. I've got the cube root of 2 to the first. In order to have a cube root of 2 cubed, I would need to multiply by the cube root of 2 squared. So I'm going to multiply this fraction by the cube root of 2 squared or the cube root of 2 squared. Now this is what's different, okay? Before, with square roots, you multiply, if that were 1 over the square root of 2, you'd be multiplying by square root of 2 over square root of 2. The reason that works is if you've got 1, 2, if you add another one, then you've got 2 of them. You've got a perfect square. Here I need to get a perfect cubed. So if I only got 1, 2, I'm going to need 2 more to get a perfect cube. Everyone see that? So on the top, I've got the cube root of, what is 2 squared? 4. On the bottom, I'm going to have the cube root of 2 cubed. What's the 2 root of 2 cubed? Cube root of 2 cubed is what? 2. So this is the cube root of 4 over 2. Okay? So similar concept. You just have to get used to that same question. What root are we taking? How does that help me organize what's under the radical? Okay? Because this was cube roots, if I had 2 to the first, in order to simplify anything with a 2, it's going to have to be 2 cubed. Well, if I've got 1, I'm going to have 2 more. That's why I multiply cube root of 2 squared over cube root of 2 squared to get rid of the radical. So let's look at the next one here. It's going to work very similar. The key is look at the denominator. What's in the denominator? Cube root of 5. Okay, how many of them do you see? How many 5s are there? 1. How many do I need to get it 5 to the cube? I need a total of 3. If I've got 1, how many more do I need? 2 more. So I'm going to multiply this by what? Yeah, cube root of 5 squared. So here's my original. I need to multiply by the cube root of 5 squared over the cube root of 5 squared. So my whole goal is on the bottom, I want a perfect cube. If I've only got 1 5, it takes 2 more to get a perfect cube. So what do I have on the top of the fraction? So I'm going to have cube root of, what's 5 times 5 squared? Well, it's how many 5s? 3. So I've got 5 cubed. Multiply this times 1, and you get the cube root of 5 squared. On the bottom, what's the cube root of 5 to the 1 and 5? How many did I get? 5 cubed. That's what I wanted, okay? Cube root of 5 cubed. Now we simplify. What's the cube root of 5 cubed? 5. Plus cube root of, what's 5 squared? Yeah. You could leave that 5 squared. You could write it as 25. Doesn't matter. What's cube root of 5 cubed? 5. That's your answer. Okay? So this is an equivalent expression to the one we started out with, but there are no radicals in the denominator. Okay? So the key difference here is you look at what you start with. Cube root of 5 to the first power. I can only simplify cube roots if I have a perfect cube. So to make this 5 cubed, I have to multiply by 5 squared. So cube root of 5 squared is what's going to make that the cube root of 5 cubed. If I multiply the denominator, I also have to multiply the numerator by that same expression. Okay? Sort of okay? Okay? Okay, good. Now, look at the next one and tell me what to do. What you want to start out with, what's a simple, you want the denominator to be as in simple form as it is before you start doing anything. So Kyle's pointing out something. The denominator is what? 3, because 3 to the 4th is what? Is 81. So I can save myself a heck of a lot of work on this one. This is 2 times the 4th root of 10 over 3. That's the rational form. So this one was just thrown in there to trick you, but you didn't fall for it. Okay? If you didn't know that, you just look at 81. You know, you divide it by 3, you get 27. And then this starts to look familiar. Okay? That is 3 to the 4th. You can always figure that out, whether or not you memorize that fact. I think we're down to the end. Okay. So, this one, I want to rationalize. So you want to look at, first thing to do is look at the denominator. Okay? What do I see? 4th root of what? 4. Okay? So, is there any way it can be simplified or rewritten or what? Okay. What about if I did this? 2 plus the 4th root of 8 over the 4th root of 2 squared. Is that the same thing? Oh, yeah. Okay. So, if I'm going to take the 4th root, I want the 4th root of a perfect 4th, not square, okay? That's 2 today. One more and you're out, okay? So I appreciate it. I like the participation, whether they're right or wrong, okay? So we're good. So, I'm taking the 4th root of 2 squared. What I really want is the 4th root of 2 to the 4th. How many more do I need to make it 2 to the 4th? 2 of them, okay? So, if I multiply this by 4th root of 2 squared over the 4th root of 2 squared, okay? I'm going to get there. Now, if I didn't see that, this is the 4th root of 4. So that would have been what? 1, 4, and you had to multiply by the 4th root of what? 4 to the, no? If I didn't write it in terms of 2, if this is the 4th root of 4, that's one of them, I would need 3 more. 4th root of 4 cubed. Then I would have to do a lot more simplification. Anything that you can simplify up front makes your life easier, okay? So this is going to be, when I multiply the top, I get 2 times the 4th root of 4 plus the 4th root of, I'll have to see if I can simplify that. That's 8 times 4, right? 8 times 4 over the 4th root of 2 to the 4th, okay? You got 2 squared and 2 squared, that's 2 to the 4th. The whole reason we did this was so that the denominator simplifies. So what do we have here? So we've got 2 times the 4th root of 4 plus, pardon me? And then I've got the 4th root of, what is that, 32? Divided by what? What's the 4th root of 2 to the 4th? 2. Okay. Now I got to look at this 4th root of 32. Is that as simple as it can be? Divide it by 2 and you get what? 16. Divide that by 2, you get 8. You get 4. You get 2. Do I see 4 of anything? Yeah, I see 4 2. So this is 2 to the 4th times 2. So I get 2 times the 4th root of 4 plus the 4th root of 2 to the 4th times 2 over 2. What's the 4th root of 2 to the 4th? That is 2. So I get 2 plus, excuse me, so 2 times the 4th root of 4 plus 2 times the 4th root of 2. All of that divided by 2, right? Yeah. So 2 over 2 is what? 1. This final answer is 4th root of 4 plus 4th root of 2. Okay? A lot of work in that one, okay? So the whole key here is to be very sure about what you're doing. What root are you taking? How do you organize it? What does it take to rationalize a 4th root versus a 5th root versus a cube root, okay? You've got homework.